Good morning, everybody. We got a Kollmorgen bus power supply, model number PSR45A-250. It had a shorted regenerative braking Igbt in there. This right here is shorted on these two terminals right here. So I put a new Igbt power module in there, and I checked the regenerative braking circuit to make sure that no damage was fed back up the gate. Everything looked good. So let's fire this thing up. Let's see if the braking circuit is working. Now I've got the fluke oscilloscope there to the collector of this power module inside, and we're going to go to bus ground with the black lead. The red lead looking at the collector and the black lead on bus ground. Got a light bulb bank over here to simulate the regenerative braking resistor. Let's get you close to the oscilloscope so you can look at the waveforms. Now it's nice on this bus power supply, when you turn the line voltage, when you turn the 220 off, the regenerative braking circuit fires. So we can test it by turning the line voltage off. Okay, I'm going to power up the control voltage by applying 120 volts AC to the C1 Molex connector. There's the cooling fan spun up. Now I'm going to turn on the line voltage, the 220 volts AC, three-phase. And we're sitting at 293 volts DC. Now I'm going to turn the 220 volts AC line voltage off, and we'll see if that regenerative braking circuit fires. There it is. Did you see that? We had a bus voltage up here. I turned the line voltage off and we saw it firing. Now since the line voltage is turned off, our bus is going to drop to 0 volts DC. Turn off the control voltage. As soon as this gets to 0, I'll turn that control voltage on again, and we'll apply the 220 volts AC, three-phase. I'm going to spread the time out a little bit so we can see those pulses a little bit better. Okay, that's close enough. There's the 120 volts AC on the C1 Molex connector. Here's the 220 volts AC three-phase. Okay, let's turn the 220 volts AC three-phase off. There, did you see that? That's cool. That's close enough. Let's turn that control voltage off. Over here is where the control voltage, the 120 volts AC single phase, comes in on these two pins right here. Now the outside pins, the ones I'm not connected to, they're in parallel, so you can connect to either one of these 4 pins right here. Now these top 2 pins, they're a normally open contact. Now it's open, and if the DC bus is applied and there's no faults, those contacts will close. Over here is our control voltages, the DC voltages that feed over to the drives. And we're going to measure that here in a second. We're also going to measure the DC bus here. Let's get my meter over here. Is there a place where I can park that where y'all can see? Pull this back a little bit. Maybe I can stand that drive up. There we go, that's good. I can reach around it. We just put 120 volts AC on this connector. We're going to apply the line voltage. There's the line voltage. Let's measure the DC bus. 293.4 volts DC. Let's measure these voltages. Now they're in parallel also. This third row down is ground. There's plus 23.62 volts DC. There's minus 23.63 volts DC. That's good. Let me switch hands here. We don't want to short this out. Get back on ground. The third row down is ground. And there's 13.11 volts DC. That's good. Our voltages are good. Let's check that relay and see if it's closed. Our DC bus LED is on. Our regen LED is off, and our fault LED is off. Put this in the beep mode here. Set that down on there. Don't short out. Now this contact should be closed. There we go. The relay contacts are closed. We fixed it. Part here, CM100DY-12H by Mitsubishi. These two contacts right here are shorted. That's your regenerative braking IGBT. Here's the shorted regenerative braking IGBT. Now they only use one. They use terminals C2, E1, and E2, these two right here. This IGBT over here they don't use, and so they short the gate emitter with a jumper wire for the unused IGBT. This over here is the gate emitter for the one that's being used. Let's set our meter in diode test mode, and we'll show you the short. Here's C2E1, collector 2, emitter 1, and E2, emitter 2. That's a slap dab dead shorted right there. Now if we go to C2E1 to C1, we have a good diode drop right there, 0.375. Now we lucked out on this. The circuitry that drives the gate emitter of that shorted IGBT, the circuitry inside that Kollmorgen bus power supply is good. It's not damaged. At the end of the video, I'll show you a little bit of the circuit there that drives the gate emitter. I mapped it back into the power board to make sure none of the gate emitter circuitry was damaged when this shorted out. We can see real quick if we have a short. Yeah, it is shorted from gate emitter short of 0.077 diode drop. That's not good. Let's go over here and look at the good one. That's what it should look like. An open circuit. So we did have a short circuit event on the gate emitter, but it didn't damage that circuit. We really lucked out there. Evening, everybody. Now here is the circuit that drives into the gate of the Igbt in the regenerative braking circuit. Now the Igbt was shorted, so I wanted to come back up here and make sure that the driver circuit here, the gate driving circuit, was not damaged. Now here's a connector that connects the gate emitter of the Igbt to this circuit. Now the first thing I saw was this 47 ohm resistor, so I threw my meter across there and it was good, 47 ohms. I came over here to this stage and put my meter across the NPN transistor, base to collector, base to emitter, collector to emitter, and that wasn't shorted. Oh, good. Then I come down here and did the same thing on this PNP transistor, base to emitter, base to collector, collector to emitter, and that wasn't shorted. All right. So we're good so far. Now down here is the yellow LED on the front of the bus power supply, and it turns on when the circuit is firing. So I come back here and look to see where the bases were going, and they're driven on by these two comparators, LM339. Both outputs are tied together and joined to a pull-up resistor of 2.92K. I didn't bother to go any farther back. The 47 ohm resistor was good, not opened up. The two transistors were not shorted. So I felt very confident that this circuit right here, the comparator circuit, was good, and I didn't bother to go back any farther. Might do that in the future if I ever need to, but this was enough to tell me that the circuit here was good. Now if I'd have found an opened resistor and shorted transistors, I said, yeah, I might want to go back and work this circuit out and manually drive this circuit after I replace all the bad parts. But there was no need. Everything here was good, and so there was no need to go back any further. Well, there you go. Thank you for stopping by and taking a look at my drawing. I hope y'all are having a good day. We'll see you next time.